Thank you very much. Hello, everyone. This is Bekir Pekmezci from Istanbul Technical University, Turkey. Today, I'm going to be talking about utility of glass and carbon fabrics in ultra-high performance cementitious matrices. We have been using very much of TRC made out of ultra-high performance matrix for several purposes, and we need to characterize the mechanical properties for design issues. The motivation of this experimental study is to know the composite behavior for use as cladding panels, as you see on the left-hand side, and repair composites over here, and strengthening or retrofitting system. Here in Turkey, we do use prefabricated UHPC panels reinforced with carbon and glass fabrics as cladding panels. We also started to use these composites for repair works of reinforced concrete buildings. And we are very much using FRCM composites for strengthening, either for historical masonry or for reinforced concrete building, especially at the beams and floors of those. The objective of this experimental study is to characterize the mechanical properties of various FRCM systems with UHPC matrix and varying fabrics inside. So I can say the first objective is to compare the properties of both composites with UHPC matrix and with normal strength concrete matrix. I mean, I'm meaning a mortar with 70 megapascal of compressive strength as normal strength matrix. And the second is to compare the properties various reinforcements in UHPC matrix. The first one was glass fabric and the second was carbon fabric. Let me make the definition of UHPC here in this slide. UHPC, according to ACI 239, UHPC is a class of advanced cementitious materials with greater strength, tensile ductility, and durability properties when compared to conventional or even high-performance concrete. The expected properties are homogeneity enhancement by eliminating coarse aggregates in the matrix, and the second is density enhancement by optimizing the packing density of the matrix. This is achieved through optimizing gradation and mixture proportions between the main matrix constituents. And the third is the ductility enhancement by introduction of fibers. But in our case, we did not introduce fibers into the matrix. We added glass and carbon fabrics, and we increased a little bit of ductility by introduction of these fabrics instead of introducing fibers here. So I have to say here that it is, I mean, increasing ductility a little bit with using fabrics might be valid only for thin materials. The experimental study, details of experimental study. In the experimental study, glass and carbon fabrics were used. The unit area weight of glass fabric was 340 grams over square meter. Glass fabrics are coated with styrene butadiene rubber to facilitate handling and in application. The coating amount on the fabric was approximately 50 grams per square meter. The unit area weight of carbon fabrics, excluding coating, were 300 grams square meter. Again, a spare coating was applied on carbon fabric as well, and sand was applied on the surface of the carbon fabric to increase the bonding properties. Two types of packaged dry mix mortar was used in the experimental study. The first one was UHPC mix. UHPC mix had the minimum 120 megapascal compressive strength, maximum 1 millimeter dimension of quartz and polycarboxylate type, superplasticizer, and ordinary Portland cement 52.5 and silica fume. And normal strength mix was having 70 megapascal compressive strength, 1 millimeter quartz and maximum dimension polycarboxylate, superplasticizer, and ordinary Portland cement. It does not have silica fume. This is the specimen preparation. We did apply first layer of the mortar, and then we put the fabric in the middle of the sample, and then second layer of the mortar was applied. Following the curing time in the sealing conditions, the metal plates were glued by means of epoxy resin. Then tensile tests were applied according to ICC ES 434 testing protocol. If we get to test results, composites produced with carbon fabrics showed significantly higher load values. These are the test results of 120 megapascal UHPC matrix composite test results. This is for the comparison of glass fabric reinforcement and carbon reinforcement. However, glass fabric reinforced composites showed higher extension than the carbon fabric ones. The first part of the graph reflects the properties of uncracked section, while the second part is reflecting the load extension properties of cracked section. Here, the slope of carbon reinforced composite is much higher than glass reinforced one due to high elastic modulus of carbon fibers. Here in this slide, I showed the performance of carbon reinforced cementitious composites in different types of matrices. So one matrix is 120 megapascal compressive strength matrix, and the second is 70 megapascal compressive strength matrix. Although both composites showed similar extension values, utility of carbon fabric in UHPC matrix showed significantly higher load values. Here in this slide, in comparatively lower compressive strength matrix, the comparison of two fabrics is shown over here. Glass fabric reinforced matrix showed higher extension values. Carbon fabric reinforced matrix showed higher tensile loads than glass fabric reinforced one. Here again, the slope of crack section is much higher for carbon reinforced composite than the glass fabric reinforced one. This slide shows the glass reinforcement in two different matrices. If we compare the performance of glass fabric in UHPC and 70 megapascal matrix, glass fabric reinforced UHPC matrix showed slightly higher load, while slightly higher load values, while showing slightly higher extension as well. So here in this slide, you see the samples after failure. So I mean, it's just a photograph, but you see the very fine cracks in all the samples. So these fine cracks helps to improve the energy absorption during the test, during loading. This is the microstructure of glass fabric reinforced matrices. The left-hand side, you see the 120 megapascal matrix, and the right-hand side, you see the 70 megapascal matrix. So this is the scale. This is 300 micrometer. It's very. focused picture. So what we see here is the dense structure of UHPC creates better bonding with SPR coating of glass fabric. We can conclude that better bonding from the matrix residue on fabric after failure. So you see over here in high strength, high performance matrix, the bonding is better. The residual, the residue of the mortar on the fabric is much higher than the lower strength cementitious matrix sample. Over here in this slide, you see the same comparison for carbon fabric. This is the 120 megapascal matrix, and this is the 70 megapascal matrix. But the difference here from the previous slide is you see more mortar residue on low strength matrix than the glass fabric. The reason for having this mortar on this carbon fabric is the sand particles on the SPR coating that increases the bonding. When we get the conclusions, we can conclude this experimental study as in samples produced using 120 megapascal UHPC matrix, the composite produced using glass fabric exhibited considerably lower tensile strength than the composite produced using carbon fabric. However, the deformation amounts of the composite containing glass fabric are higher compared to the composite containing carbon fabric. Carbon fabric composites have higher tensile strength in case of using high strength matrix. The deformation amount of cementitious composites containing carbon fabric did not change significantly with the change of matrix strength. SPR coating plus sand application on carbon fabric provided satisfactory bonding with cement matrix with a considerable amount of matrix adhering to the surface. As a result of microstructural observations, it was determined visually that the high performance matrix showed higher bonding with both types of fabric. The effect of increasing the strength on the matrix on the composite performance of carbon reinforced composites is higher than that of glass reinforced composites. And I have to mention that the results are valid for the material used in this experimental study. Thank you very much for listening to me.